Okay, Mike, whenever you're ready, I'll start the clock.
Yeah, cool. So first of all, it's great to be in the epicenter of farming, downtown San Francisco. Hopefully, if I do my job and you're interested in ag tech, you'll learn one or two new things and go away with a fresh perspective on farming and what it really means. We're going to do a couple of things as a business. Number one, we're going to help farmers and growers rebuild soil fertility. Some biogeochemists predict in the world that we've got about 6 decades left of topsoil at current depletion rates. And if we're going to increase productivity on the farmland, it begins with the soil fundamentally. The second thing we're going to help farmers do is increase the efficiency of water. I don't know if you know about this drought that we're having in California, but NASA scientists predict that we've got about 1 year left of water resources left in their particular state. Water efficiency is a permanent problem in the state of California. We're in permanent drought. And the second thing we're going to help, or the third thing we're going to help farmers deal with are those things that impact their crops. Bugs that want to eat them, pathogens that want to destroy them. 40% of the world's crops are destroyed by pathogen and insects every single year. And it turns out that the way we're going to solve the problem is by helping farmers go biosustainable at massive scale. If you're thinking about agriculture and you're not thinking about big scale, you're thinking about gardening. Gardening's really cool. We want to think about agriculture at great scale. The source of the solutions that I just mentioned, which is rebuilding soil fertility, water efficiency, and dealing with bugs and pathogens, can be found in about 1.5 billion tons of cellulosic waste material produced every year just in North America. That's a massive amount of feedstock that is available for companies that know what to do with it. What will we do with it? We'll take on an average of 1 ton and we convert that into 300 kilograms of biopesticides, 300 kilograms of a soil amendment called biochar, 190 kilograms of high-quality bio-oil. That's 790 kilograms on 1,000 kilograms. If you do the math, that's 79%. The balance is natural gas that is all found in that lignin cellulosic material that we use to continually run the reaction. That means we use zero energy, we produce zero waste to produce biosustainable products that help farmers. From a unit conversion perspective, that means we can buy biomass at $35 a ton and we convert that into $1,055. The unit economics of a business model like this can be amazing. The products are also natural. They're natural because nature's been doing this since the very first forest fire, not the forest fires we're used to today, but slow-burning forest fires. That stuff that looks like smoke that's sort of wafting in that forest, those are condensable gases that we're able to monetize. That carbon that is left afterwards, that is the soil amendment that we use. But of course, you can't build a business around forest fires. You've got to build a business around great engineering, which is what we do with our platform. We're able to convert lignin cellulosic materials into 3 high-value derivatives simultaneously by using completely natural processes I just described. So, you know, plants have an immune system. That immune system is based on a whole variety of phenolic compounds that plants use to ward off plant-eating insects and pathogens. We simply collect that material in the huge volumes and apply that back to the crops. Let me tell you about Rick. Rick is a certified pest control advisor for 30 years. He advises 21,000 acres of certified organic cropland in California. He thought I was nuts until I showed him how quickly our material can kill bugs. Now, the only thing more exciting than watching grass grow is watching bugs die. So I'm going to accelerate a little bit on this for you. Here we're spraying it. This is at, 45 seconds. We're spraying the aphids on a kale crop. By the way, if you see aphids on your kale, don't eat the kale. It's not that good for you, despite what all the bug guys are telling you. And then if you look out here at about 1:15 seconds, so 35 seconds later, those bugs are dead. That's actually a pretty good deal. Now Rick Click, as opposed to telling me that I'm a snake oil salesman, is telling all of his farmer friends that they should be talking to me, which is a really great tipping point. So the material that we use, PLA, it's called pyroligneous acid. It's a spectrum biosustainable pesticide at a dilution rate of about 100 to 1. 1 gallon in 100 gallons of ag water kills bugs. At 500 to 1, it stimulates the plant growth. If you want to get technical, I'll be at the bar like most people are right now a little bit later, and we'll dive into that. At 1,000,000 to 1, at 1,000,000 to 1 dilution, those materials produced in plants can neutralize an acre-foot of water, 1 full pH unit, and neutralize the carbonate salts that are in there. So the applications to the farming operations are massive and broad spectrum. Let me tell you about the biochar soil amendment. Rebuilds soil health, cuts water up to 50%, improves the yield up to 50%, and cuts the fertilizer, fundamentally because it absorbs water and it holds the nutrients. This is what strawberries look like on biochar: 50% increase in yield, 50% increase in pricing compared to other products. This is what my measly backyard looks like on April 20th and on June 15th with a single cubic foot spread out over the lawn. The agronomic benefits are amazing, and by the way, it doesn't hurt the good guys. That's the way nature and evolution works. We're just leveraging nature and evolution. I want to leave you with one final thought with regard to something that everybody in the room should care about, which is the environment and climate. I'm going to finish up with this particular slide. If you take biomass and you let it decompose, that turns back into natural gas and feeds back into the atmosphere. If you turn this into a format that microbes cannot digest, it remains in this format for thousands of years. In our business model, photosynthesis is the largest mechanism the world has ever known to suck CO2 out of the atmosphere, and we've got potentially the largest mechanism in the world to take that carbon and stick it into the one reservoir that it does great things for farming, and that's the soil. Thank you.
Thank you, Mike. Thank you.
Thank you for your presentation. It has been astonishing for the eyes, but everything that you say sounds very good. But I'm wondering, do you have any scientific knowledge backing up that information? Any white paper, any university behind?
Yeah, quite a bit, actually. On one of these slides where I showed you all of the bugs, those are actually links to abstracts that I could show you where scientists have tested it on those variety of bugs as well as fungi. And there's a lot of literature in the scientific domain around biochar in agronomic applications. So there is a lot of science behind this. But we're also doing our own field trials, like with the USDA. When I told them about this concept, they had no idea what I was talking about. Now they're testing it on navel orange worm, which is a huge pest for tree crops. I think there's an almond farmer somewhere in the room. Ambrosia beetle, as well as citrusilids, which is the bug that is destroying America's citrus crops. So there's an awful lot of science behind it. I can give you all kinds of links offline. Yeah, for sure.
Mike, so is this destined to give Monsanto's Roundup a run for their money?
Well, Roundup is an herbicide. This can work as an herbicide at high concentrations, but we haven't gone through the whole business model on the herbicide application.
Okay. My apologies.
But we think it'll give a lot of synthetic pesticides a run for their money. That's what we're focused on.
Hi, could you just repeat what you were talking about on citrus screening and how your product would combat citrus screening in more detail?
So we don't have any data that it works on Asian citrusilids, but we have great data that works on navel orange worm and other things at extraordinary dilution rates.
Okay.
So the USDA has said, you know, the bugs clearly hate this. So I don't have any scientific data or field data on that particular bug, but we're working on that right now in a quarantine facility to see where it works. So wish us luck.
Okay. Thanks.
Thank you.
Quick question, where are you guys located in headquarters?
We're going to be right over the Altamont Pass in the Tracy area.
Hi, Michael. So I'm really curious with a lot of the farmers going into drip irrigation. there becomes a problem when they do drip irrigation instead of flood irrigation, that the water is not filtering through to go to the aquifer and to replenish the aquifer. And then you have soil that ends up being salty. So what's happening when they go to drip irrigation is destroying the soil. How can this help the farmer? Do you have the test results on how this can replenish the farmer, in particularly in the almond industry? They're having major issues with this.
Yeah, the principal problem with salt is calcium sulfate salts. And so adding sulfuric acid will often convert that into CO2 and gypsum. And the way that you do that is adding sulfuric acid. So I asked scientists at a major research institution not too far from here, between here and Sacramento, how this would actually work, and asked them to titrate this and then do the ionic measurements as well. Because that's precisely the problem we're trying to address, which is if farmers like your operation are pulling up well water and salting the land and really, cutting off the nose to spite their face, so to speak, they're dealing with really expensive water and they don't have surface water, so they're pulling up well water but destroying the land long term. We think we can ameliorate that problem for $2 an acre foot. Yeah.
Any other questions for Mike? Asking all crops?
So the issue on neutralizing water, so it's not about the crop, it's about the water. So yeah, that's just the chemical issue. When you talk about crops, that's an agronomic issue. So yeah, it'll neutralize water just generally. That's acid-based chemistry. The question is, from an all-crop standpoint, is what pH do certain crops prefer? Most crops like it slightly acidic, not slightly basic, which is what we have throughout California.
All right, we're out of time. Mike, thank you so much. Corigin. Good stuff.